Example 7a. Find the cosine of theta if the sine of theta is negative 1/4 and theta is in quadrant 3. I'm going to use the sine squared plus cosine squared equals 1 identity, but I'm going to use it in the form that's been solved for cosine, since cosine is what I'm looking for. So cosine of theta is either plus or minus the square root of 1 minus sine squared theta. But the problem tells us that theta is in quadrant 3. In quadrant 3, the x's are negative, and therefore cosine is negative. So I know that cosine of theta will be the negative square root. So at this point, we have cosine of theta equals minus the square root of 1 minus sine squared theta. We put in negative 1/4 for theta. Squaring it, we get then minus the square root of 1 minus 1/16. So minus the square root of 15/16, which is minus the square root of 15 over 4. Now, example 7b asks us to do the exact same problem, except with the information that theta is in quadrant 4. In quadrant 4, cosine is positive because the x's are positive there. So all the steps are the same as above, except that we're using the positive square root. Cosine of theta will be the positive square root of 1 minus sine squared theta, so we get positive 15 over 4. Example 8. Find the secant of theta if the tangent of theta is 20 over 21 and cosine of theta is negative. So I'm going to use the identity that involves secant and tangent, and I'll go ahead and use it in the form secant squared of theta equals tangent squared of theta plus 1. Solving that for secant, we have secant of theta equals plus or minus the square root of tangent squared of theta plus 1. Now to choose the square root, we need to know what quadrant theta is in. Notice that tangent of theta is positive. Tangent of theta is positive. That tells me that I'm either going to be in quadrants 1 or 3. But I also know that the cosine is negative. So I can't be in quadrant 1 because cosines are positive there. I must be in quadrant 3. Therefore, secant will be negative. By the way, in this particular problem, I really didn't need to figure out exactly what quadrant theta is in. Just knowing that cosine is negative actually gives me that answer, because the secant is 1 over the cosine, and if cosine is negative, then the secant would be negative as well. But I wanted to point out that we can actually, from the given information, figure out exactly what quadrant theta is in, and you do sometimes have to do that. You have to go through that whole reasoning process. Okay, so back to the problem. We have secant of theta is the negative square root of tangent squared theta plus 1. So that's minus the square root of 20 over 21 squared plus 1. So minus the square root of 20 squared over 21 squared plus 1. And I multiply the 1 by 21 squared over 21 squared to get an LCD. At that point, under the square root, we have 20 squared plus 21 squared over 21 squared. The denominator simplifies because the square root of 21 squared is 21. And in the numerator, we have 400 plus 441. So we have minus the square root of 841 over 21. Now, it turns out that square root does actually simplify. It turns out that 841 is 29 squared. That's not something I would expect you to be able to do without a calculator. But I went ahead and did some investigating to see if I could simplify the square root, and I used a calculator, and I figured out that 841 was 29 squared. So the final answer would be negative 29 over 21. And you may need to use your calculator like that on the homework problems. On an exam, I won't make the numbers hideous like 29 squared, so you won't need to use a calculator on something like this on an exam.